not straightforward if it's brand new. So if one-step equation involved removing one number, obviously two-step equations means there's going to be two numbers attached to the x. But the goal is the same, right, Yanesa? The goal is what? To find x, right? To find the value of x. So I'm going to kind of teach it the same way. I'm not going to vary my method at this stage. So I'm going to draw my, and that just divides my left and my right-hand side. So you can see, let's just take a look. The x is on the left-hand side. I've got two numbers attached to it, right? I've got the 3 attached to it with multiplication, and I've got the 5 attached to it with addition. Okay, so we get rid of, it's kind of the opposite of what we do with BEDMAS in a way. We get rid of the add subtract first, the very first one that we learned in the one-step equation. We get rid of the one that's furthest away from x, in other words. Like this, it almost looks like the multiplication, like they're so tight together, it's like the 3 is glued to the x. So that's the last one we get rid of. So I'm going to get rid of the positive 5 first. Well, how do I get rid of a positive 5? I subtract 5. So I'm left with a 3x on the left-hand side, and what do I have on the right-hand side? 6, okay? Now can you see I'm at the stage I was at the last part of yesterday's class? I'm removing multiplication, right? I removed multiplication with division. So I'm left with x equals 2. Now yesterday we were asked to verify. I'm not going to verify all of them, but I will verify this one just to show you how the verification works with a two-step. So with verification we sort of use this T-chart, and we've got a left-hand side and a right-hand side just like the equation does. And I substitute my answer, what I think the answer is, into the correct side of the equation. And I want to, notice how I don't put an equal sign here though, because I don't know if it's equal or not. That's what I'm trying to verify. 3 times 2 is 6. 11, perfect. 11 equals 11. Now I have verified my solution. You're verified when your left hand equals your right hand. Okay. Let's try example 2. Now, I said yesterday, and it still goes today as well, it doesn't matter what side your x is on. X can be moved to the other side, but if it's on the right-hand side, no big deal. You can solve, x can end up being on the right-hand side. Like, it doesn't matter what side x is on. All you're doing is trying to isolate it. So I see that it's attached 6x minus 93, so I'm going to add a 93 to both sides. That leaves me with just 6x on the right-hand side. 9 plus 93, 102. And then last step is divide by 6. 17?
Yeah.
Okay, try example 3. Okay, so let's do that. Okay, so I do this, and that might be a good thing for you to do. And now look for the side where the x is. X is on this side, right? These are the numbers you're trying to remove. So you're trying to remove the 12 and the 5. We're going to remove the 12 first, right? So how would I remove the 12? Minus 12, yeah. So whatever you do to one side, you do to the other. So that'll leave me with a 5x on this side, and then 97 subtract 12, 85, I think. Yeah? And then what? What's my next step? Yep, divide 5. Divide 5. I showed my division yesterday just using the bar system. It's a more sophisticated than doing the bar dot dot. It also, that's how we basically show our math in as we move up the math levels. So then I have x equals 17. Same answer as the previous question, right? And if I want to really check all my answers, in reality, you should always check your answers, right? It's a good thing to do. Sometimes we run out of time, but it's always good to check your answers. So if this is where a calculator can be a nice learning tool for you, just a nice homework tool. You can say, okay, well, 12 plus 5 times 17, am I right? Yes, 97, right? Just to check your work. Now, on the yesterday we were being asked to verify. So sometimes on a test I'll ask you to verify, right? If I ask you to verify, this is what I'm asking you for, that T-chart. Okay. All right, we've got 3 more examples. They're the same, right? So you might be thinking, why all the examples? Well, we're trying to cover all the different scenarios where you might run into where the x is and how it's attached to all the other numbers. So division, this one involves division, right? I have x divided by 2, subtract 7, equals 11. Okay, so I look wherever the side with x is, the left-hand side. So those are the numbers I'm trying to eliminate, right? I am trying to eliminate the divide by 2 and the subtract 7. So what am I going to go for first? Jordan, do you know which one I'm going to get rid of or remove first? The 2 or the minus 7? Any idea? No? Can anyone help Jordan out?
Plus the 7.
Yeah, the 7, the one that's furthest away, right? So I'm going to add a 7, add a 7. Okay, so that leaves me with x divided by 2. Okay, so just say to yourself, what do you have, right? What do you see here? If I'm going to verbally explain this problem, it's going to be x divided by 2 equals 18. Just focus on the x divided by 2. X is being divided by 2. So you're trying to get rid of a divide by 2. The opposite of divide by 2 is multiply by 2. Mm-hmm. And I said yesterday, like, calculators are really nice little learning tools, and any good calculator, I think, like sometimes you get some of these calculators that are really wonky, but any decent calculator, the buttons are even set up that way. So add and subtract, I'll undo each other, so they're usually side by side on a calculator. And multiply, divide, undo each other. They're inverse operators, so they're usually side by side. Okay. Example 5, are we good so far, or does anyone have any questions? Example 5 is a tricky one. I'm going to let you think on that one for a minute, okay? I want you to think on example 5 and 6, are tricky ones.
Is there a test for this next week?
We're going to have a hand-in assignment tomorrow.
Tomorrow?
Yeah. Do you have to leave right now? Or?
I got to leave in a bit. And yesterday I had to go to a basketball game, so
Yeah, we're gonna have a hand-in assignment during class tomorrow.
The online thing, right? Or
It is.
it is?
It's been working for a while now. Yeah, it was only last week it was glitchy. You're all caught up so far.
Okay, thank you.
Should be working. Okay, what's tricky about example 5? I'll tell, like, I think it's a tricky one. Anyone? Or maybe you don't think it's tricky. Maybe I shouldn't.
I think it's tricky.
Devin, what makes this one different from example 4?
We are done on the denominator instead of the numerator.
X is in the denominator, right? That makes it tricky. So there's more than one way to get us out of this sticky situation, because it's like 2 is being divided by X. So I don't even have an explanation. X is kind of part of it's not the main player in this question. So how do I get myself out of this tricky situation? I need to get X out of the denominator. Like, because I think everyone will agree that when X was in the numerator, it was easier to solve, right?
Change it into a multiplication.
Okay, how do I change this division into a multiplication question? Nadia? Flip it? Just flip the whole thing? You got the right idea. How do I change this? Yeah.
Yeah, put the X on the other side.
Okay. Can I just like move it up?
Yeah.
I can, can't I? So Jordan is saying, okay, take the X and just move it up to the other side. Okay. So it becomes a multiplication.
It's gonna be 20.
Okay, and that actually works. Why does that work though?
Because there's a denominator under 10, which is 11, and one of the leaders multiplied.
Yeah. So one of the ways you could do this is, yeah. I'll just explain it now what Eunice said. She said cross multiplication. So, do you remember when, and I know I've said this before, on the overhead or on the board a few times when we were talking about equivalent fractions, do you remember when I said that? Like 1/2 equals 5/10? Agreed? And I said a couple of things. I said, okay, well, 1 divided by 2 is 0.5, 5 divided by 10 is 0.5. That's how I know they're equivalent fractions. The other thing I said is when you multiply the numbers, like if I do diagonal lines here, and when I make diagonal lines joining the numbers diagonally, I get thanks. Physically, I get this kind of an X form, or people might describe it as crossing. I'm crossing numbers, right? When I cross and I multiply, 1 times 10 equals 2 times 5. That will always happen in equivalent fractions. Okay, so you were given, it doesn't look like you were given a fraction here, but you were. Okay, any number, any whole number can be written as a fraction. So anytime you have a fraction equal to another fraction, I can use that cross multiply thing that Jordy told us about. He said he can get the X up on the top really easily in the numerator by just cross multiplying. So if you're given the equal sign and you're said that you've got a fraction equal to another fraction, that means 2 times 1 equals 10 times X. Okay? And now it's easy to solve, right? Or fairly easy. So now my X is here. So I have 2 equals 10X. X is attached with multiplication. So I divide out, right? So X equals 2/10. Can I simplify that in any way?
1/5.
Yeah, or X equals 1/5. So the key is getting, but cross multiply only works if you have one fraction equal to one fraction, right? That cross multiply method only works if you've got one term in fraction form equal to one term in fraction form, okay? Now let's look at the final example here, the trickiest of the whole group. 4 divided by x plus 7 is 19. It's the same kind of setup as 5, except even trickier, because there's that plus 7. Now remember I said to you, cross multiplication only works when you have one fraction equal to one fraction or a number. And I've got this number here. I want you to think about this for a sec. It can be solved the same way as 5, but you have to do one little thing first.
Just get rid of the second.
Yeah. Did you do it? Try it. I don't know if you heard Bianca. Bianca said, just, or why am I calling you Bianca all of a sudden? Blanca said, just get rid of the 7. Get rid of the 7.
It's like, there's two, I don't know what it's called, binomial, no.
Yeah, it's a
One
binomial. You know what? I should be using those words, right? It's a binomial and a monomial, but it only works if it's monomial equal monomial. Cross multiply only works if it's mono equal mono. Like this one was mono equal mono, right?
Oh, so you went 7,
Yeah.
for the 19 as well?
Yep. So whatever I do to one side, I do to the other, because an equation is balanced, like those, we used to have those, oh, like those scales, or no, not those ones. You know those ones with the 2 trays? So if I take 7 off of this side, I have to take 7 off of the other side. So then I have it, whoops, 4 over x equals 12, right? Okay, so now I'm at the stage again, right? Unesa, monomial equal monomial. Now you can do it. Okay, what's my next line after this? If I have 4 divided by x equals 12, and I kind of use that cross multiplication thing, what do I get? What's my next line?
3.
No, my next line would be what?
4 equals 12.
4 equals 12x. You jumped right to the answer, Unisa. And then I'm going to divide by 12, right? So then x equals 4/12 or 1/3. X equals 1/3 is a better answer for us because we spent a lot of time reducing fractions. Okay. Okay. Those are tricky. Those are the trickiest ones you'd ever have to do when x is on the bottom of a fraction. So do whatever you can to get it into monomial form, and then you can do a cross multiplication. We good? Yep.
How will you verify that?
That's an interesting question.
Yeah, that's what I was gonna ask. 1/3 plus 7 isn't 19, is it?
Okay, let's see. Did I goof? So I'm verifying that 4 divided by 1/3 plus 7, and I'm trying to see, that should equal 19, right? Okay, division of fractions. I'll write it out this way. Okay, so remember how we divide fractions? What do we do if there is no division of fractions? It turns into a multiplication, right, of the flip, 3/1, which is just 3. Okay, multiplication comes first. 4 times 3 is 12. 19. I'm glad you asked that question though, Jordy. Okay, 19 equals 19. Whew. Scared me there. Okay, let's try example 6, kind of for fun. This is kind of it's a question that doesn't have any context. We're not solving for like the cost of something or how much dosage to give to someone. Those questions are coming. So this is just a really abstract question. A number is tripled, then reduced by 5, resulting in 13. What's the original number? So you could do a guess and check, like just start playing with numbers. You know the number's not going to be super big because even if it's reduced by 5, resulting in 13, but there's an algebraic way to do this as well. Okay, so let's just talk about this. When you're given a math question where it just says a number and you're looking for what is the original number, well, you're looking for an unknown number, right? What have we been calling our unknown numbers in all these questions? What was our unknown known as? X, right? So we may as well, you can call your unknown any letter of the alphabet, but I think just to keep things familiar, this is what you do have to state in math problems. Let the unknown number, we're kind of strict on that you have to make a statement of what you're solving for, and you can't just pull an X out of the air without stating what it is. So the unknown number is going to be called X. Okay, this unknown number, X, is tripled. How do I show that? How do I show a number being tripled?
X cubed.
That's X being cubed. That would say X cubed. The number's cubed.
Multiplied by 3.
Yeah, it's 3 times the number, right? So a number is tripled, so 3x, reduced by 5. Reduced is another word for, subtract 5. Resulting in, what would that be another word? Equals 13. Okay, so now you should be able to find the number, right? Okay, what's the number?
6.
Yeah.
Because of the way it was written out, if my brain worked different and I didn't do it the algebraic way, I just knew that 13 plus 5 had to be divided by 3.
That's perfect. Yeah, you're doing the same thing. You're working from the question, right? You're working backwards. Or you're working from the answer. You were working backwards. That's great. Okay, so we have some time. Remember, classes doesn't end till 10 after, right? So you guys, I know this is a weird class because it starts a bit later and it ends a bit later, right? Because there's that 10-minute break. So you've got time, like we've got almost 20 minutes. So try these questions, the two-step questions. A couple of, you can use your calculator if you need to. I don't think you'll need to really much. You might want to use it for those decimal questions. We are going to be doing a hand-in assignment tomorrow in class.